Hi everyone, welcome back to CoreNCode. In this video series, we are learning UART communication between STM32 and Raspberry Pi step by step. In the previous video, we completed the hardware connections between STM32 and Raspberry Pi. In this video, we will configure UART using STM32 CubeMX. Before configuring CubeMX, let's quickly understand how UART works. UART is a method used by two devices to communicate with each other. UART stands for Universal Asynchronous Receiver Transmitter. UART uses two main signals. TX is used to send data and RX is used to receive data. TX of one device always connects to RX of the other device. Now, let's understand the UART frame format. Every UART data is sent in a small packet called a frame. The frame starts with a start bit. This tells the receiver that data transmission is beginning. After that, the data bits are sent. These bits contain the actual data, usually 8 bits. Sometimes an optional parity bit is added. This is used for simple error checking and is often disabled. Finally, a stop bit is sent. This tells the receiver that the data frame has ended. So this is the UART frame format and how data is arranged inside a frame. The same things we just saw, data bits, parity and stop bits, are also configured using UART parameters. One important UART parameter that we have not covered yet is baud rate. Baud rate defines the speed of communication. In simple words, it tells us how fast the UART frame is transmitted. For example, a baud rate of 115200 means 115200 bits are transmitted every second. Both devices must use the same baud rate, otherwise communication will not work. Now that we understand these parameters, let's configure USART1 and USART2 in STM32 CubeMX. Now let's open STM32 CubeMX and start the configuration. I will create a new project. I'm using the board selector. And I'm selecting the Nucleo F411RE board. CubeMX opens with default configuration. First, I will clear all pin configurations so we can configure everything from scratch. Now, go to connectivity, enable USART1. USART1 will be used for UART communication with Raspberry Pi. I am enabling USART1 in asynchronous mode. CubeMX automatically assigns PA9 as TX and PA10 as RX for USART1. Now let's look at the USART1 parameters one by one. Baud rate is set to 115200. Word length is 8 bits. Parity is set to none. These settings must exactly match the Raspberry Pi UART configuration. Now I am enabling USART2. USART2 is connected to the ST-Link virtual COM port and we will use it for debug messages on the PC. USART2 uses PA2 for TX and PA3 for RX. USART2 is also configured at 115200 baud with default UART parameters. This way, Raspberry Pi communication and debugging remain independent. Next, we check the clock configuration. No changes are required here. Now, go to Project Manager and give the project name. Select STM32 Cube IDE as the toolchain and click on Generate Code. CubeMX will now generate the code and opens the project in STM32 Cube IDE. Click on Launch. This will open the project in STM32 Cube IDE. Under the project, go to Core, then src and open the main.c file. Here you can see the generated UART initialization code with the same parameters we configured in CubeMX. This code initializes both USART1 and USART2. And that's it for CubeMX configuration. We have understood UART basics and configured USART1 and USART2 using STM32 CubeMX. In the next video, we will start writing the application code in STM32 Cube IDE.